All right, so this time what we're at is we're after the distance between 2 points, okay? So take a look at this picture right here. So instead of finding the midpoint, what we're after is we're after the distance from this point all the way to this point. So we'll call that D. So it's the distance between 2 points. And then I'm going to give you the formula. So the formula is still going to use these 2 points like we did before, all right? Those are our 2 endpoints. And then here's the formula. So what you have to do, and here's how I want you to remember it, is you have to subtract the x's and you have to subtract the y's. Then you have to square both of those numbers. Then you have to add those together. And then you have to take the square root of that whole thing. So that's your formula for the distance between 2 points. And actually, this is where like the Greeks, this is where they discovered that there was irrational numbers, okay? This is going to come out to be some weird square root. Oh, I messed up. Yeah, sorry. Yeah.
Yeah, what am I going to use this in real life?
Well, if you want to find the distance between 2 points.
What if I'm working?
So, hey, again, I'm recording, so I need a quiet, please. Again, I need a quiet. My brother-in-law, he works at an electronics plant where they make circuit boards for like the military and NASA and all that kind of stuff. And they use all these formulas all the time because they're trying to drill the circuit boards and make the, it's like a circuit diagram basically. So they use all this stuff all the time. But I did make an error here on my formula. Rachel, that's supposed to be a Y1 right there.
Got it. Oh, on the right?
Yeah, right here. That's supposed to say Y2 minus Y1. Now, guys, when we were doing the slope, it was important, right? The order. Like if you did Y2 minus Y1 on top, then you had to do X2 minus X1 on the bottom, right? Or if you did Y1 minus Y2 on the top, then you had to do X1 minus X2 on the bottom. So you had to be consistent with the order. But on this one, the order doesn't matter because, like, if I was subtracting these X values right here, let's just make something up. So if I was doing 5 minus 2 squared, isn't that the same thing as 2 minus 5 squared?
Yeah, because it'll be positive.
Yes. Do you guys see that? Because this one's going to be 3 squared, right? This one is going to be negative 3 squared. Are those the same?
Yes.
What do they both equal?
9.
Yeah, they both equal 9. 3 times 3 is 9.
There's no way it says.
Again, guys, I'm recording, all right? So 3 times 3 is 9. Negative 3 times negative 3, that's also 9, right? So really, inside those parentheses, the order is not important. Okay, you just got to subtract the x's and you got to subtract the y's. So let me get this stuff out of here. We don't need that. All right, so let's try one of the examples here. Now this one, I'll go ahead and I'll draw you a little diagram again just so you can see it one time. So let's draw a diagram for this one. Let's see, so we're at negative 2, and then we're at 4. All right, so let's say negative 2 is like here, and then 4, 3 is like up here. So what we're trying to find is the distance between these 2 points. So again, we're after this. We want to know how long that distance is. And again, this is the point A, which is at negative 2. This is the point B at 4, 3. 4, 3. All right, so let's try this formula. So we're going to subtract the x's. So what are my x's?
-2 and 4.
Yep. These are my x's right here, right? So let's subtract them. Doesn't matter, either order. I'm going to do 4 minus -2. Remember, you're subtracting them. Remember, when we were doing the midpoint a minute ago, you were adding the x's, right? Now you're subtracting them. All right, and then what are my y's? -2 and 3. And really, the order that I do it doesn't matter. And then from there, what do I do with both of those things?
You square them.
I square them, good. So now we're going to square both of those. And then what?
You add them together.
Good. And then what?
You take the square root.
Perfect. All right, that's it. So that's how I want you to remember it. Subtract the x's, subtract the y's, square them both, add them together, take the square root. So what's 4 minus -2?
6.
That's 6. So we got 6 squared. And 3 minus -2?
5.
That's 5 squared. And then we still got to take the square root. So what's 6 squared? 36, good, plus,
25.
yep. 5 squared is 25. So now add those together under the square root. What's 36 plus 25?
61.
61. Now 61 is not a perfect square, right? So we're going to get some kind of weird decimal that goes on forever and never repeats.
Yeah, it's like 810.
Okay, hold on, let me punch it in. So what is it, square root of 61? Now this is how the Greeks discovered that there was these other kind of numbers that were irrational. All right, they were trying to find, you know how they like to build all that stuff? So they were building stuff, and they needed to know the distance from this point to this point. And then they were like, what happened? They couldn't figure it out because it wasn't a fraction and it was not a whole number. What's this other weird irrational numbers, like the square root of 61? Okay, that's how they discovered the irrational numbers. So the square root of 61, now they'll tell you to round off in the book. We're going to round off to the nearest hundredth. So it is, what do we got here? So I got 7.81024. We're going to round off right here. We're going to keep 2 digits after the decimal point. So we look at that next digit right there. If that number is 5 or larger, then we would round up. So this one we don't round up, right? It's just 7.81. The square root of 61 is the exact answer. 7.81 is a round off. So that's your distance. You guys good? All right, let's do another one. Again, I guess I can put this up here. So that distance on my picture here then, this was approximately 7.81 units. So if that grid was in feet, then that'd be 7.81 feet. Okay, if that grid was set up in miles, that'd be 7.81 miles. All right, so on the next one, I'm not going to draw a picture. We'll just do it. So let's do this one. All right, see if you guys can tell me the steps here. So what do I do first?
Fill in all your numbers.
Yeah, wait, how did I say it?
Oh, x2 minus 1.
Subtract the x's, right? What are my 2 x's?
20 and 3.
So 20 minus 3. Then what do I do? What do I do after that?
29 minus 11.
I'm saying what's the process? I said subtract the x's. What?
Subtract your y.
Subtract the y's. What are the y's?
29 and 11.
So I'll go 11 minus 29. All right. Then what do I do with those?
Square both of them
Square them, good.
and add them together.
And then add them together,
And then take the square root.
and then take the square root, good. All right, so 20 minus 3, that's 17, so I got 17 squared. Plus 11 minus 29 is negative 18 squared. And then take the square root. Now you guys could always put that whole thing in the calculator. But make sure if you're squaring that negative 18 on that calculator, you got to put the parentheses in there. Otherwise, it will give you the wrong answer. If you put it in just as negative 18 squared, it's going to come out with a negative 324, and that's incorrect. You guys should know that negative 18 times negative 18 is going to be positive, right? So 17 squared was 289. And then, I don't know, is 18 squared 324? I don't remember.
Yeah.
Is that right? Did you try it, Rachel? Did you type that in?
Yeah.
Okay.
It's 613.
613. So we need the square root of 613. That's the exact answer.
24.76.
Yeah, and then you got to round it off. So I'll double check this. Yeah, so I got like 24, what do I got? 0.7588. So we're going to cut it off right there. So this digit right here is a 8. So what do I do with that 5?
Turn it into a 6.
Yeah, if I'm going to round off, if this number right here is 5 or larger, then I round this number up. So 24.76. So this is approximately 24.76. Let me erase this out of here. And I'll erase this out of here too. All right, flip it over. We got one more to go. But it's the same thing.
When we write our answer, do you want us to write it as the decimal or just as this written?
It tells you in the book.
Oh,
And it'll tell you what to round it off to also.
got it.
So this one, here's your story problem, but it's the same thing. It says each unit on the grid is 100 meters. And then it says how far is it from the roller coaster to the Ferris wheel? So we want to find this distance from here to here, right? So we're after that distance. Okay, so you guys walk me through this again. What do I do first? Other than Rachel, what do I do first? Damien, what do I do first?
You subtract 2 with the 8, no, with the 6, sorry.
Yeah, subtract the x's. That's what I wanted you to say.
Yeah.
So subtract the x's. So the x's are 6 and 2.
Yeah.
So 6 minus 2. Then what do I do? Say it to one. What do I do? What do I do to the y's? Subtract. Yeah, subtract the y's. So 2 minus 8. And then what do I do with those numbers? Yep, square them. And then what? Add. And then what? Square root, yep. There you go. That'll give us our distance. So 6 minus 2, that's 4. So we got 4 squared. 2 minus 8, that's negative 6 squared. And then take the square root. And then 4 squared, that's 16. Plus, what's negative 6 squared? Yes, it's not negative. And it's not negative 6 times 2, okay? It's negative 6 squared. That means negative 6 times negative 6. Ethan, knock it off, please. So that should be a positive 36. And then that gives us 16 plus 36. What's that?
52.
52? And then we gotta take the square root of that. So that's our exact answer, is the square root of 52. And if you read the directions, this one said round off to the nearest whole meter. So the square root of 52 is, again, it's an irrational number, right? It's 7.2, I can't even read this. 1110255 right? And that number keeps on going forever and never repeats.
So do you just round to 7 then?
Yeah, then it said round off to the nearest whole meter, so we're going to round it off right here. So since that next digit is a 2, if this digit is less than 5, then you leave this one alone. So it's just 7. So it's approximately 7 meters.
Do we have to multiply by 100? Because it says each unit represents 100 meters.
Oh, I didn't think about that. Yeah. Yeah, each unit on the map represents 100 meters.
I would have laughed. So it's just 7.
Yeah, I didn't think about that.
Yeah, 700.
Yeah. Yeah, so guys, quiet down again. I'm recording. Yeah, you guys got to go back and read this right here. I missed that. So if you read this right here, it says each one unit on the map is 100 meters. So that means really when you look at this point 2 comma 8, that's really at 200 meters comma 800 meters. Yeah, so we got to fix that. So let's fix that. So get this out of here. So it's 7. So we're really going to take 7 times 100 then.
So the distance is roughly 700 then?
Yeah. So it's 7.